All right, howdy, folks, and welcome to stream number 5 of Alwa's NES Awakening. We're porting Alwa's Awakening to the NES. So last time we made up this palette or this tile set for Forsaken Valley, and we've got most of what we're a good starting point anyway. And we opened things up into tiled just to tinker a little bit, and we have our tile set here, and we're able to build screens in tiled. One thing that we want to figure out here relatively quickly is how to keep track of the attribute table, which palette is being used for the tile set, because tiled isn't specifically a NES tool. It's just a tile set tool for any game development platform, really. So tiles can have extra properties, but I'm not sure how to do this. Let's see. So my idea was to have the palette being used, or the attribute table number, contained as a custom property. There might be a better way of doing this, but see if we can figure that out. So if we click on tile, it tells us what our ID is over here, which is the number. I want to add something I'm not doing right. So let's read the manual here. Firefox just crashed. Why are all of these things on the wrong screen? Oh, they're on every screen apparently. Anyway. Custom properties, I think that's it. Yeah. Basic data structures, custom information can later be used by your game, which is what we want to do. Yeah, plus button. Oh, the bottom of properties view. Yep. Plus button. Why not? Why? Doing something wrong here. Huh. Can't add the property. So I click Edit Tile Set. Maybe that's my problem. One of these buttons. New, embed, export, edit. Ah, there we go. So we have to be in the tile set setting here. Are we able to? That's the other thing, is keeping track of like collidable or like tiles that cause damage. Let's see. So palette as an int. Okay, so custom property. So that one's palette 0. We can change it to 1. These don't have them. What if we select a range, add a property, yeah, so we can do it for a range of tiles. I guess you have to specifically go in and add it. It's not like a new property that we can quickly assign, but so we can have a palette number. What happens if we select all this? We just add it to the entire thing. So everything is 3. I can select this, change it to 0. So now this is 3, now this is 0. Yeah, so we can just select the whole thing, add a property, palette, default to 0, and then we can select ranges. Say this is palette or 3. Okay. Say this is palette 2. And this is palette 1. So now let's see what happens when we export that. Export CSV. Those are with Vim. Come on. Always. Why not? All right. Oh, we're dropping frames. What's the deal here? Oh, wired. Not that many frames. My CPU. Keep an eye on that. Wonder if, I don't know. So we've got, I don't see our custom data. Just our tiles. Types tiles, what are those? I don't know. Expert formats. Okay, so maybe CSV only supports tile layers. Maps containing multiple. Each tile ID, unless it has a custom property called name, in which case its value is used to write out the tile. What? But that's So I want to export that. CSV, it only supports tile layers, but that's all we're doing. Maps containing multiple tile layers will export as multiple files. But we only have one tile layer, I think. Each tile is written out by its ID, which it did. Unless the tile has a custom property called name. So if it specifically has a custom property called name, in which case its value is used to write out the tile. Oh, but we don't want to change. We still want the we don't want to overwrite name. We still like the number. So JSON is the most common. What if we export to JSON? What happened? It just keeps exporting to the thing we last did as. Export as. Yeah, it just overwrites our last. Let's try JSON. I don't really know what JSON looks like, but people talk about it a lot. Open. So let's see. Yeah, that's. Oh. So there's a layer. Huh. Still not seeing. Export custom property. Custom property tag, most of them 0, but few is 1. Yeah. They exported and actually saw that. I didn't. It's tile properties. I wonder if it's not part of the map. So I can't find format. So the quoted number represents the local ID of the tile in the tile set, which you can look up in the tile properties. So I wonder if these tiled properties yeah. So let's export as a JSON. Export the tile set. So these custom properties, yeah, it would seem they are part of the tile set and not part of the map, which isn't really. I get a grid of all the tiles from the map. I was hoping to have something similar for the properties, because then that's basically the attribute table data. but that's not what we get. Shoot. Well, I guess, I don't know, there's probably some create some sort of map function to create that conversion ourselves, or oh, this is tile number in this range, therefore it's palette number whatever, but and I don't, thinking about how to, there's just more information in there that we want as far as collidable and things like that. Storing all that information, I'm not sure. Write some of this down. This is not a palette plan, I think. So if it's collidable, damage, palette, so the end goal we want a couple things. First thing we want is stream of nametable data, which is the tile numbers, and this is given to us by the export from tiled map. I'm pretty sure I have to brush up on the format of things, but that should be fine. I hope. Not should, but okay. And stream of the attribute. So we can, we can store it in the tile set, but that's we only get that from the export of a tile set. Overall, that's not a lot of data, because for a given tile set, somewhat got arranged in blocks, and so part of me says you could have it would keep the amount of data down by having the NES process that tiled as it's loading attribute, or as it's loading the name tables. It could have some sort of lookup table that's like, okay, well then we need to put the attribute table, that tile number is this palette number, and so create the attribute table while we're doing it, which wouldn't be that fast, but we're not actively scrolling. When we're scrolling, that's all we're doing. Maybe it's okay. Or alternatively, do it ourselves, do it during the compilation, or as a it's not. Anyway, those seem like the two main options. We also need, so in so the 6502, well, it doesn't necessarily have to be in RAM. So for the collision detection, as Zoe is walking around, we need to be able to detect, and that's in the, we want that in the CPU address space. And so the CPU address space, I mean, once the data is loaded, once all the tile sets and everything is loaded into the PPU, then all the 6502 cares about is how to interact with the background. And because we effectively don't have this, our background is so complicated that using larger meta tiles, I don't know how people normally do it, but I don't know how much I care. I'm probably reinventing the wheel to some degree, but the collision data should be able to be in a 16 by 16 in a meta tile state or format. The tile data doesn't work well in that. We basically want 8 by 8, but collision wise, everything is pretty blocky. I don't think we have any issues. Sticking with 16. Well, and part of the thing is some of these tiles, and just realizing this now, but like this water, this well, it uses our bricks tiles, but it's not collidable. You walk in front of that. So number a given tile doesn't always have the same. Well, it doesn't always have the same palette number because the way that we're getting extra grays, which might change mine about that, but same palette nor collision. Made up of bricks, extra gray. I guess the question is what all information do we need to have stored in tile data? So custom so collidable not spelling that right, I'm sure. Is it collidable? Is it deals damage? Is it a ladder? Well, I guess generically speaking, is it interactable or not? And then these are the types of interactions that we can have. We can collide with it. It can cause damage. We could climb it. Some of these things we can shoot it. There's these doors. Key, so we can use a key. Some of these, I guess we would consider it as an enemy as far as these little birds that spit fire. We don't really care. But we are going to have to we are going to have to store the enemy information as well. But as far as shoot at it, oh, there's little blocks to step on. The little switches. But those are going to be sprites, but at least I think. But how much? It's still in terms of when we're processing collision information, is it has an XY position, which we need to know. So part of me says, if trying to think of create a data format, I think we can just have it if it's 0, we don't interact with it, we'll pass in front of it. We also have like water to interact with. When our little block, when we push into it, push our little block into the water. So part of me is thinking just having to start, we can just have a grid with the interaction types. Keep it basic into something that should cover all cases, and then we can think about condensing that. If we only need 16 interaction types, perhaps, then we can get by with maybe a nibble. But if we just think of it as a byte, and maybe we can okay, so I think we can do this on a meta tile basis. And so our map is 32 by 26. But our interaction grid uses 16 by 16. I don't know if I really want to think of it. I don't think they're meta tiles in the common sense, but we're kind of separating these two things. So we have, instead of 32, it would be half that, so 16 by 13. So how many bytes is that? $208. So if that's 208 bytes, that's not too bad. that leaves 208 minus 256. If we think about it as a page, it leaves 48 bytes. So assuming this is just going to be ROM data, sorry, kind of recovering from a cold here. This ROM data, 200, doesn't contain any of the name table data. It's just our collision. So we have a map function, whether or not we're colliding with the background. Curious. How many screens do we have total? Well, it's the whole thing is 19 by 35. $665, but that's maybe 60%, 70% full. Let's just say 70. It should be less than 500. So if there's 500 screens, then there's 500 pages. And a page is 1/4 of a kilobyte. So that should fit. Of ROM. That's a lot. It should be fairly compressible. And so that's where we run length encode or something, and then we could give up a page of RAM, assuming we don't have RAM on cartridge. I don't know what it would compress to, but to some degree. Thinking of it, well, if it's gonna be in ROM uncompressed, it's gonna take up more data. Oh, well, I was trying to think of what this data changes. like these blocks. I think once you break them, they're gone forever. I don't remember. These type of little blocks. Definitely the keys. Once you interact with them, they're done. How to deal with that? I think these types of things, once they're gone, but maybe I don't remember, but once you beat bosses, they're gone. But that type of information, we're gonna have to have some sort of separate I don't know how to think about that yet. But even like collecting the little gems, whatever they're called. Excuse me a second here. The little gems, there's all kinds of information we're gonna have to store. Things that are done or not. And we are gonna have to reference that as we load. But that, a couple different ways. Part of me likes the idea of trying to store that information in like a 4K byte sector, a bank, because if we like to be able to utilize flash saves, and like to have 3 slots at least, and so that hopefully that's enough. Items collected, unlocked. If we need more, we can use multiple sectors, but so the other this interaction grid or data set, I think we can also have it contain things of that nature, of enemies, because because we've separated it from the tile data, it's all of the information that we need to know when loading that screen. And so maybe we can use certain bits of that byte to say that it's an enemy type spawn. But then we're going to have to animate that enemy, move him on the screen, which is going to be something separate, but that'll be effectively contained in the OAM buffer. But so we could have it so persisting info, go look up the stored data table. So as we're processing that, if we run into certain byte numbers or whatever, that's where like a gem is an item that you only collect once or you only interact with once. Go look up the flash data and figure out what to do there, and then come back. And so yeah, as far as creating this information, hey Koitsu, how are we doing? I like the idea of doing it in tiled. I mean, certain things we're gonna know. I think there's extra layers we can create for objects. Let's look at that quick. Objects. Spawn points, source code. Start using object layer. Yeah, so what do the export of objects look like? So game maker object. That's all I'm really talking about. I don't know. I guess I'll just have to deal with it, but anyway. So our object layer. Don't really know what I'm doing here, but inserting these different things. Each type of object has its own placement tool. Maintain additional data files for storing gameplay elements. With addition of the tile objects that can also be used for graphical purposes. What tiles can be inserted as objects? What kind of data does it give us? There's a square. That's great. Tile layer. File. Save as. Oh, export. This. Where? Yeah. So it's in our JSON file objects telling us information of where it's at. I don't really know. I can create them. I guess I don't know what I'm doing, but I have a hard time imagining how this. I mean, I guess it tells me, but part of me feels like it's easier just we know exactly where these things are. I'm not designing the game from scratch. So anyway. Okay. So what do we want to do here? I don't know. We want to get tiled data loading up in an NES ROM, because that's how we want to build our screens. Even if so, maybe we should just try to not one step at a time here. And see if we can just export the tile information and load it up in a screen. So let's this was what we had from NES Screen Tool. If we export from here, it's interesting. You can export or import a bitmap as a name table. But so name table, save name table only. This is 0313. See what that looks like. I think, yeah, it's just gonna be, it's not a text file. Open it. Hex editor. Okay. It's just binary data going from the top left. We got a bunch of tile zeros. We got 2 rows of them. Let's change this to 32 bytes. Hey, look at that. Some ASCII art of our screen. So there you can see the exclamation points, our cross beams. We got quotes for the downward cross beams, our ladder, just a little D, Enye. So we don't have a binary export of tiled. We have a CSV. We have Lua. I kind of like the idea of Lua because I'm familiar with it, and it'd be fairly easy to create scripts to convert to go from Lua to like a binary format, or we're probably going to want to run length encode them or something. So writing those things in Lua sounds kind of appealing. Let's export as Lua and see what that looks like. Oh. We're actually, this is the tile data. Yeah, this looks like the tile. Which, oh, maybe I have to have, looks like the object layer, mini map. Yeah. Okay, so if I have the tile layer selected, export. What's going on here? Oh, yes, load it. Oh, it's all, is everything there? Doesn't look like a Lua file. Anyway. Encoding Lua. So it is giving us all the information of ID, number, the palette. It looks like it's giving us all the tile data, the tile set data. And then it's giving us the tile layer. And then it's giving us object stuff. I guess these are dictionaries, tables. I don't use a whole lot of tables in Lua, so I'm not. Doesn't look like a Lua code that I write, but I'm guessing I figured it out. Anyway. No. Table constructor. Yeah. So these are just a bunch of Lua tables. So okay. Oh. I mean, really the format. I'd like to have is a run length. But it could be as an RLE file. Let's save it as that. And let's also save as RLE and a C header. And that's what I was running as previously. So let's look at the RLE. Looks like a nested hash, not particularly useful. Yeah, I'm not sure. I'm assuming you're talking about the Lua data I was discussing earlier. So the RLE format, I think it's something like 9 zeros, 9 1s. I forget the format exactly, but there's some tag. I think it's this at the end is supposed to tell us what it is, or it means something. Anyway, it should be the same data. Bunch of zeros, and then 01, 02. Oh, okay, yeah, so tile number 9, and then there's 1F instances of that previous tile, which 1F is 32, 16. Brain is not. Yeah, 31. Yeah, because 20. Well, maybe it's saying it's always at least 1, and then so there's an additional 31 that follow, and then it just has. But this isn't even that good of a compression. I mean, I guess it's better than nothing. We've got 296 versus 3C0 because it's a whole name table is 960 bytes. And I don't know if I really want to come up with my own compression scheme, but lots of times it's the two tiles right next to each other, like the little bricks. Tile this one, then that one, and this one, then that one, and this one, then that one. So if I came up with my own RLE format that instead of just saying, here's the tag is 09, what tile number? It could be 09 and then 0001, and then when it finds the next tag, then it tells it how many times to repeat. InfiniteNesLives matter. Yeah, there's a NES forum thread on different compression formats if you want to try several. Yeah. Excuse me for a second. Sorry about that. Yeah. So you can look up some different compression schemes, and ultimately going to be kind of implementing these. Well, anyway, Yeah. I think I've seen Breakolad's thing. We'll take a look at it real quick. Name table compression format. Yeah. So, either way, tiled is giving us a table, it appears. Let's look at this again. Forgetting my Vim. Anyway. So we have tables of tables for the tile sets. I'm just going to do it because percent. I thought I did that. Oh. I did control percent, that's why. Yeah, so we got tile sets is and then we have layers. So this is in the layers table, we have different types of layers, tile layer, and then tables of that. So anyway, I have to tinker around with Lua to see if we can get at that data relatively easily, but if we just had binary data to get started, uncompressed, had that working, yeah, okay. Yeah, I got some of my Sunsoft 5B programmable boards. It's a pretty popular one due to lack of donors. Yeah. Trying to make some decisions of how to move forward. Let's kind of I'm just gonna jump into some Lua. Hey, look at that, it's already here. I don't know how we... I don't know how to... So let's... Vim... That's a terrible name. Create. Just not Prince. Back to the basics on Lua. So used to just jumping into my projects. They're already, stuff's already set up. But if you are following along and want to, sometimes it's helpful. Just print Lua. We're using the Euro interpreter prompt. What? That's okay. It just runs the script. I don't necessarily need a main. I think I'm thinking so. We want to open or import I'm just going to reference my own code. So this is my retro programmer thingy. So local require and the file name. What do we call it? Test. Create name table. No, that's the file. That's a script that we're working with. Test 2. Close this. So this script is just returning a bunch of tiles. So let's print test2 dot version. See what happens. Attempt to index global test2 a nil value. Did I import properly? Oh, tiled, we called it, not test2. There we go. So we're reading data from let's try to read the tile set name. So tile sets and then tilesets.name. Yeah, so Koitsu said there's no braces around the function comment. Oh yeah, I'm a little behind here. So I guess I figured out. Okay, so tile sets that name. I think some of this stuff, there's multiple ways of doing it. Nil. And maybe that's because, so there's tile sets. I think that's what I need to call the table. Yeah, tile sets is a hash of hashes. It'll have to be iterated over, like in a layer. Yeah, I think it's in Lua speak, it's a table of tables, but same idea. I'm no expert though. Where was... So yeah, so the a dot name is just syntactic sugar for a same thing. So we could have done tiled like Koitsu was saying, square brackets version same difference, just syntax sugar. So we want to iterate over the elements. I always have a hard time with these. Confusing a dot x with a brackets x. The first form represents a quotes, that is the table defined by the string x. Table of tables, dicks of dicks. I guess I'm a Perl nerd, yeah. But same idea. Second form is a table indexed by the value of the variable x. So we have a table, x is a variable y, a of x is 10. So conventional array, you can use integer keys. Iterate over the elements in an array. First is it's interesting. So we got, it must be an address or something. So being dumb here, but so why can't we just say why doesn't that work for, it's a table Yeah, doesn't work. But print all the keys for table T. Suppose we have a table, days of the week. I don't know what I'm doing. Oh, so Koitsu is saying try tilesets 0.name. Oh. Or 0.0. I don't, but 0, there. Seem really we want something like that's even glorified JSON maybe. Oh, try it. What did I mess up? Oh, do it. No, it doesn't like that. Wait. Try and do an object-oriented. What? Good old Stack Overflow. Let's just go back to the okay. Figure this out. This is extra boring. But so for just a I don't know if reading this aloud to you guys is any fun. Probably not. Tables in Lua are neither values nor variables. They're objects. If your idea of an array comes from C or Pascal, you have to open your mind. Think as a dynamically allocated object. Your program only manipulates references or pointers. You do not have to declare a table in Lua. In fact, there's no way to declare one. You create tables by constructor expression. I think like everything is a table, but okay. So we have table A, and then a variable k is equal to x, and then we say table element k equals 10, but k equals x. Table, so key 20 is great. New entry with key 20 equals great. So to print a of k, which was x, that's a 10. K equals 20. So then we can access it. We said 20 equals great. So a of x equals a of x plus 1 increments entry of x. Yeah, that evaluates to 10 plus 1. They're always anonymous. No fixed relationship. So b equals a. B refers to the same table. Print b of x gives us the same thing. Because what if we created a new table in Koitsu's got it. If we create a new table and say it equals to that other one, so he's saying it's thing tile sets 1, 2, dot name, etc. Oh well, that might be part of the problem. Is he might have Lua starts at 1, yeah. There we go. Nice work, Koitsu. Hope I'm saying your name right. That's how I've always said it, so as far as I'm concerned, that's how it is. Yeah, so this is saying, yeah, okay. So tile sets index. I guess one thing that I understand is why do we say the one? The first, because we can. Oh, because this is the first, and I think only. Because it's a tile, or because it's a table itself. Yeah, it's a dict of dicts. That's why. And so if there were these are entries. Where's this one end? Tile sets. So that tile sets goes to layers. And then this is another. Yeah, it seems like it doesn't really. Well, there's only one entry. We've got two. It's curly brace. So there is only one. So we're telling it. I think that's where. I missed it because tile sets is an extra one. Okay. So we've got tile sets. We can access our items there. We want layers. So let's print layers height and width. Okay. Now that worked. Let's print. Let's print some data. So now this is an extra. Before we were just referencing variables. Here it's another table. What? So data 1. Is that just going to be 242? Yeah. And if we did data 2, the second tile, 243. Okay. So we've got our actual data there. So what I kind of just want to do is create a binary file and convert these items into binary and write them to a binary file. So this is something that I'm somewhat familiar with. Let's So I don't know. So file, dump file, so local, we'll call this just name table dot. Oh. Say this is so I think that'll just create a file for us. Name table.bin. Okay. So it went in and created that file. All right. Binary files. So input and output. So IO write. So it's saying F equals the file, and then F colon read. So I think we just do file write. We just do io.write, but let me tell it what file, because it's already open. So this example, dump binary file. Okay, so we wrote the letter L into this file. Now we just want to format it in binary, which you do something like this. String byte. Yeah, just a string format. Let's write the number 1. No? Why is that not? Delete that file. Try it again. Why? Oh, is that a 1, not an L? Am I confusing myself here? Okay. Yeah, that's the ASCII 2. I want to write oh, I think that's not right. I think this is byte B in this example. Let's just do this for now. File write So we have the number. The first tile should be 242. Oh, data 242. Oh, because that's what we printed. Get rid of that. So now it should just be the number 242. But that's the ASCII representation. We want the binary. Yeah, I'm used to that string format. That just converts the ASCII into a hex, but it's still printing it in ASCII format because that's when I'm trying to print things to the screen. We need converting to binary. Well, shoot. So we just were byte B. Let's just do that. Let's see what it does. $32. That's not the right part. Okay. So raw binary string. So G sub 2 hex from hex. Try those. So we want to go 2 hex. I'm not used to that calling format. Oh, I don't think that's okay. Two hex. Koitsu has got a little example for iterating over another tile set. Take a look at that. What am I doing wrong here? Two 1D3. What? this is the same thing that I was doing before. String to byte C. G string G substring function C. Because let's just go back. So there we write the number 242. But we want to why am I being so dumb about this? Yeah, these younger programming languages work with binary data, and they are a pain. I do it all the time, and I don't even know how I'm doing it. The binary data I'm considering as a string when in my program for when I'm dumping cartridges and everything, but it's like I figured it out once. And then I never really touched that part of it again. And they don't work well with this. But sort of get what we're doing these functions. And it's so this one is from hex. So substring, what are these? To number 16 to byte string dot byte. Write bytes. This Okay, so G sub has 3 parameters: a subject string, a pattern, and the replacement string. Basically, you substitute a string for the pattern inside that string. So that's just substituting function string to hex. Is that why it was? Because I wasn't saying. So just being dumb. Two hex with a nil value. I don't think it matters. Oh, maybe it does. Okay. So let's pass it the string 2. Test 2 32. That's the ASCII 2. Yeah, or definition does matter. So we have the ASCII. So let's say local tile equals so print tile okay, so tile 242. Now I want to call, but it's not a string. And that whole thing, gosh, what the... I don't get this substring function C. Okay. Return format. Yeah. Because it's a lambda. Yeah. Print integer as a binary. Because part of the thing is I'm not printing. Should work for integers or whatever too, unless it's two numbers required. String.format. Let's see. What is the... If you want to take a raw byte and turn it into a hexadecimal value, so what's that C? Is the C just the number? The literal byte. Yeah, so we called it tile. String.format 242 output F2. Right, but oh, Luigi being the best one, yeah, keep me warm this evening. So it does it, but this is outputting to ASCII. So let's see here. I'm just gonna put this visible here so we can see the stream chat. Everything Koitsu's saying here, basically telling me what to write, but okay. Yeah, so I'm trying to write actual binary data to this binary file. So I have this integer 242, and I want to write binary 242, which is F4 or F2, in binary to this file. So, oh, yeah, there's no real conversion. So I think this is what I tested this, so, and I think that was the first thing I did. Let's try it again. Because we wrote, yeah, see that writes 242. File write tile.layers1 data1. Yeah, and what it writes is it writes the ASCII 242, which is the same thing. Yeah, Lua is trying to be smart. So, which is the same thing if I were to print that, but I want. Koitsu's looking something up. So I want. I tell Lua to write 242 and it writes the ASCII 242, but I want to consider that as a byte. Yeah, so I want Lua to consider so this example, I still don't. I'll try something. See if Koitsu finds something. So, thinking of things as characters. See, there I wrote L to the file, and ASCII L is 6C. If I think of this more of as a character, so because I can write a character to a file. What's that actual conversion? What if we convert the int to ASCII? So string to int. We want string.char. Okay. EC Myers, how's progress? Well, we're going slow here, like the hat. Yeah. Okay. So we trying to convert convert the tiled Lua output into and write them to a binary file. So I'll write raw value string char which is kind of what I just string.char. My brother and his fiance gave me that. I think for Christmas. So let's see, string.char. Let's do that. Get rid of this one. Ha! So there we go. So just string to char, because it's converting the number 242 into a character. That's really where the mental hurdle we're trying to get over here is writing to this file thinking of things as characters. That'll only handle 8-bit values. 16 won't work, but the way I have the tiles defined, we only have 0 to 255. So I think that'll do what we want. So all this junk. So tiled layers data 1 did it twice. There's a helper module struct. Yeah, I think that's actually I was messing around with WX Lua, and that was one of the things that it included was everything we were doing was converting binary and raw values to hex strings, or here I did it twice. So there. Now we've got something working. So now we want to iterate. Koitsu's giving us its tidbit here. Struct pack B data 1 to be an unsigned char 8-bit. I would be unsigned int. Yeah. I think this is good enough. I'm just going to leave this in here. Whoops. Yeah, it's paste bin. So for index value in pairs data, and this is this going to be the right? Looks like it. Refer to the Lua dict in the code. So if value type equals tile layer and value data, then IO write layers. Trying to understand. What he's doing there. I'm just going to try for B in tiled layers one dot data file write on my for loops. We're not going to array of dicts actually, nested data. This is not going to work. Oh, do. That's my. Yeah, there we go. Missing that. That's all right. Oh. So I need, yeah, pairs.data.layers. So that's what I'm trying to do, and it seems like, so for index value in pairs data.layers. Okay, so the index and the value if value type equals tile layer and value.data, then I'll write you need pairs tiled layers 1 data for B in pairs. So maybe that was that close. Yeah, so for the pairs, function char out of range. Yeah. B is what we, oh, B is 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh. It's just the index iterator value. Yeah, so we need to so we want to say tiled layers, oh, or we could do that. Let's for I, B in pairs tiled layers. We'll try Koitsu's way first. Oh, it is B. What? For I and B. I'm curious. So I already have, I already have this doing what I want. I just need an iterator for this final data. Let's try what I was going to do. But all I really want is a for loop of 1 through 2, well, how many tiles do we have? Let's do what I was going to try. I think it'll do as many as there is. Tiled layers 1 data B. Did we do it? I think maybe. Yeah, so Koitsu's for I and B pairs. Yeah, so we have this for B in pairs tiles. This basically just gives us an iterator for, instead of us having to define where the end is, it defines the, it goes till it gets to the end of that. We know it figures out the last index for us. And so that gives us an iterator for that table that we can then use and write okay. We did it. I think. Yeah. I want to see something that looks like a map. So there we go. This should look like our tiled map. There. This kind of looks like what we drew. Yep, you can see our little ladder with the NES there. So we've converted tile data into binary form. Yeah, so Koitsu's saying, I'm glad I'm not the only one who looks at hex dumps this way. Yeah. Out of coffee. Okay, so that was a little painful, but we did it with much help from Koitsu. Yeah, good job to you, man. Okay. So if we look at yeah, it's the first time seeing these graphic tools. And this is, I've like seen them, but I haven't really played. I haven't done much with them. So, okay, we want to present this in the NES. It's gonna, now going back to my tile set definition here. We're going to do a bank switch so that the heads-up display has a different tile set than the graphics. Right now, we're not far enough to have that. But if we just steal our binary output from yeah, we can ink bin that sucker, but we're missing, so our tiled is only 26 tiles high instead of, what is it, 30. And so we want to have a full name table, which we got here. So the first 4 rows, So with okay, so now we've got a full name table. I forget. I've got two different. I think it's this one, ROM. Yeah, so here was our build. Let's see if we can. Just to make sure my build is working here from the one that we had previously when we exported from nope. Yeah. So I'm going to try to do some stuff in C. A lot of it's going to end up 214, yeah. I'm expecting to write a lot of it in assembly in the end when it matters, but I like the idea of proving out logic in C and then writing those functions. Somehow nothing works. Why not? I don't know. It's not giving us any errors. And I may reserve the right to change my mind. But that was kind of my idea. Yeah, this was, I don't know if this, I moved over to this other PC and we just made stuff. I might have stomped something in the process. But I don't know how much I feel like figuring this problem out right now, but we had some success there converting the tiled Lua output into binary format. Now that we have our hands on that, it should be relatively easy for us to create our own compressed binary formats, have this script, we'll have to modify it to be not have the file names hard coded and everything, but yeah, export, be able to call these files, call the script to convert our tiled files into binary, and those can just be includes in our C project. And the other thing that we'll want to do is in this doing it in Lua will hopefully be nice if we're creating some of these meta tile formats that we're talking about wanting early in their stream. So yeah, this is it may not look anything fancy, and see if it would have been nice to have that cherry on top, have my build work, but I don't know what I did. Anyway, we got our format like we wanted. So big thanks to Koitsu for helping me out there and getting us to the end. Hope everybody has a good night, and we'll see you next week, and keep things moving forward. So take it easy, guys.